All right, folks, it's just about 7. I'm gonna do a little bit of a quick introduction here before we get the session kicked off, and fortunately, that stalls us a few minutes as well to let a few other people join. But welcome to the February 2025 Greater Cincinnati Grotto Technical Topic. This is just a series of topics in caving that we found people are interested in, and it's ranged everything from rescue related topics to survey to we were planning on doing something about like how caves are made. Um, but yeah, if you've got an interesting topic that you want to learn more about, send us a message and let us know. We'll try to arrange for somebody to talk about it. And the real goal is just to learn something from other cavers, a little bit different than the typical uh, trip report sort of thing that we do with normal grotto meetings. But this month, we're going to be talking about cave survey and specifically how to sketch. For those of you who joined us back in January, we gave a little bit of a background on what are we even doing when we make a cave map. Here we're going to introduce paper sketching. There are other methods such as TopoDroid where you can sketch on a tablet, but we recognize that paper is cheap and not everybody can afford a tablet. So this is really a good way to learn the fundamentals. And I personally think that sketching on paper gives you a really good background on understanding what you're doing. And if you decide to go digital later, you'll have a better understanding of how to convert to that if you have a background in paper sketch. With all that said, we did have a couple of supplies that we had recommended prior to this session. One was a cave compass. A few of you may have that. If you don't have one, that's fine. You can just follow along with the video. And there were also a few printouts that will help if you want to follow along and sketch with us. But basically, we just want to make this accessible and highly encourage that if you are interested in making cave maps, go ahead and find a cave and just get started. Seek help from local grotto members and that kind of thing. The Cincinnati Grotto in particular, we chose a already mapped cave to go remap because the historical map was very, very bad. And notoriously, people were getting lost in there. And our new map has not only trained a lot of new cave surveyors by just getting the repetition in, but also is in progress to result in a better map. So nothing says that you can't go map something that already has a map. Just make it better, right? So with all of that said, I'm going to turn it over to Beau. Beau is our resident uh, cartography expert within the Greater Cincinnati Grotto. So we'll leave it to him to show us how to sketch.
Hello. You will not be looking at me much. We're going to look at a worksheet that we do with the class. So this is the first time we've done it online. And Stephanie started the kickoff with her PowerPoint presentation of the last session. So I wanted to review some of the things from that last session and then jump into paper sketching. It was a great intro by Stephanie. We're going to be paper sketching. We might move from my screen to Stephanie's screen sometimes, depending on what we're talking about. We're going to run through a few examples. We're going to skip some parts that we do in the in-person class because, like, in the in-person class, I'll do, or Stephanie will do one of these things, and then we'll be like, okay, now you do it, and we'll kind of help. In this case, we're not going to be pausing for the you do it parts. We're going to be showing it. If it's being recorded, it will, be accessible there, but Stephanie and I are always available. And at the end, there is a sort of a practice cave that is totally fake, but we put some data together and put some check boxes. So at the end of this, if you want to do the sort of self-test portion and try this on your own after it all, you can complete that and send it to me and Stephanie, and we'll give you feedback. And it'll pretty much run you through sketching. And it feels a little weird when it's fake like this, but this is good practice before you get underground, and especially in the online format. So reviewing, I'm gonna share. Turn that off. I'm gonna share. Make sure this. Okay, Stephanie, how does that show up? Like, like you can see my
I see
fingers.
your hand. Yep, I see your hand.
Oh, good. Okay. One thing that Stefan, I had some stuff to help me guide, like keep me on track here. So a couple things: plan, profile versus cross section. Um, Stephanie reviewed those three things at the last PowerPoint presentation. If you weren't there, that's okay. But do understand we're going to be showing how to sketch plan, showing how to sketch profile, and showing how to set sketch cross section. It's just something I wanted to note before we jump into this. Um, we have examples of it as we run through all of this for all three of these. I don't think it's worth talking about them just yet, other than a plan is sort of an overhead view. So you're looking down on the cave. A profile, you're looking on the side of the cave, and a cross section's just like a cut of the cave. But again, we're going to look at actual examples of that. Another thing that Stephanie reviewed at the last session was again, these are just my notes, but might as well keep us on track this way. We're going to talk title pages, data pages, and sketch pages. Those are the three things you'll be using on your survey. So for example, a title page, and there's all sorts of different ones out there. But a title page is something where you can mention things like the cave name, the date of the survey, the time in and out, your details of various other things that you want to keep track of for your project. There's a good on rope one title page out there that's got a ton of details, so you're never going to miss anything for the projects. This is a bit of a more open-ended one. Some title pages are literally just you knowing what to write on a just like a sketch page. So you can just write your title things on a spare piece of sketch page. It doesn't have to be a formal thing like this, but this does kind of help keep it organized, and you know that all the maybe important notes are on one page. Another thing you'll be looking at in the cave is the pages that you're going to be taking data on. And we're going to be filling these out in sort of today's session. So we're going to be filling out stations, stations. We're going to be filling out distance, azimuth, clino, left, right, up, down, or at least we're going to be getting, should refocus here. At least we're going to be getting that data handed to us, because we can't actually practice collecting that data from the computer, and that's one of the things that we're losing in this online format. With that said, though, I do want to highlight how this data is collected based on the presentation last time. So you have your title page, you have your sketch page, which you're going to be recording data, and then you have, your data page, you're going to be recording data, and then you have a sketch page. And again, there's many different types out there, but a good sketch page is going to have a place where you can write things like if it's a plan or a profile view, your scale, you always need to remember that, and which way is north. And you might even customize it, like this is the boats and hose survey. uh, so a sketch page, though, ultimately has your scaled grid, where you can choose a scale like 20 feet to the inch, and each block is an inch apart, each major block, and we divide those blocks into 10 pieces. So again, we'll get into that, but sketch page. Stephanie last time also talked about point, the three roles of the survey, point, front sites, and book. Again, there's lots of names for them, Stephanie. I don't remember the exact ones we use, but that's whatever. There's there's 3 points: the point person, the front sites, and the sketch. And I just wanted to like somehow, since we're not there in person and we can't practice this, just point out where these people would be in survey and what we're about to do after this, who exactly we are in this process. So in the back of the in the back of the at the back of the line, you'll have the book, and that is what we're doing today. And the book is usually sad because they have so much work to do. Although that doesn't mean the other tasks are easy. So we have the book. The front sights isn't far from them. I'm just going to stand them up on this rock here. I'm just going to call them front in this case. So you have the instrument person who's taking the front sights. And then you have someone further into the cave usually. And that person's usually happy. Not because their job's easy, but because they get to be in the front of exploration. And so you have your book, your front, your point, and we are doing today the book stuff. However, the front sight and point person are the ones feeding you this data that we're going to be filling out. So they're collecting this, and you're the one sort of writing it down as the book person and sketching it. And just to clarify, there's going to be like a station, like A1, shooting to the point person who set it at A2. So again, in person, we'd sort of practice doing this and then heading into what we're about to head into here. But I think just a quick visual on this front person is taking data from A1 to A2. The point person is taking data from A2 to A1. And the point person is also taking like an up, down, left, right sort of passage dimensions as well. So it's a quick recap. It's all we got here for this part of it. Again, if you do an in-person class with us or somewhere else, you get to practice this stuff in person. And we are going to move on to the sort of worksheet that we work on. What we need to make sure is that everyone knows how to graph. And what we do for find it kind of fun to start it off is talk about like drawing rocks. And I like having a method to draw the rocks because it helps make it less daunting because it's kind of weird at first. So I made up I used some methods here that you could consider. Some of them are kind of redundant, but you can kind of pick one that you like. And when you're sketching like crazy and you're doing too much at once, you can kind of fall back on one of these subconsciously and just kind of keep drawing them that way. So like, and rocks arguably make these oddly pretty maps when you have these nice rocks in it. It's kind of the one thing you can kind of spice it up with. So I'm going to run through those and then we're going to really talk about graphing. So for a little bit of fun here, just some ideas on how to draw rocks is you can kind of do this tight method where you have this outline of a rock and you put your sort of 3D part of it really tight to a section on it. And it kind of looks like a nice 3D rock there. I've seen some people do something where they sort of have this top method and it makes it look 3D by sort of having this central portion of it. So it's sort of like a 3D rock where it's kind of tight on the top and gets fatter towards the bottom. So that's an option. The mid span method, and none of these are official, just something to lighten the load off of drawing rocks. You start with an outline and you just kind of do something down the middle of it. And you can try to kind of give these the shape of the rocks for the big ones. I would not do this on when you're sketching. One, the rock might be not even important to making the passage make sense. But if you are drawing a sizable rock that makes sense to put in your sketch, you can try to start making it look like the rock. But that's sort of a later on thing. If it's a big rock, I mean, at first, it's probably best to just put a big rock in there. The outer first, then inner. You could start with the outside. This is kind of like the midspan, but then kind of jump in with an interior line. Um, so just another way to think about it. Inner first, again, you could start with the outside and then kind of jump into a an outer line. And I know they're very similar, but when I draw these rocks different ways like that, sometimes they just kind of come out differently, but it's going to be different for everyone. And then just another thing you can do is you can put, slope, that's kind of a rough one. You could put slope lines on rocks. So that's saying it's sloping, this direction. So it kind of adds it's sort of a 3D rock, but giving it additional context with a slope line. But again, the best use of your time in a cave environment that you're sketching and you might be cold or needing to get a lot of survey done, putting these on every single rock isn't going to make sense. Um, but we will we're gonna talk more about that. So just some fun. There's a method to the drawing portion of sketching. It's not all artistic stuff. So when you start, I don't think of it as an artistic thing. You can, if you're good at art, you can make it look pretty too, but it is going to go to someone's computer and they're going to probably have like symbols for all your stuff anyway. So your art might get lost in the transition to the final map. So sketching is more of a symbols and methods thing. I did want to mention we do have handouts. I kind of skipped over this. We have some like effective communication steps handouts between the point and the front sight that we're not going to go into now. But if we were practicing in person, um, getting this team to work together is really important. The information flows from front to point and both of them back to the book. So having a good team takes time, and your first survey might be pretty rough. But we do have sort of a handout on these effective communication steps. Just wanted to note that before I passed it. Um, Another thing when we do these classes, we got to make sure people remember how to graph from, probably high school sometimes is the last time you may have done it. Maybe in college. Maybe you didn't go to college. I don't know. But so we start with a very simple graphing thing. Now, and Stephanie, I'm talking to you here now too. We're going to graph this, and then we're going to graph it showing Clino. So
Yep.
we're going to address the vertical thing right after this one this time in the beginning.
Okay.
And for those tuning in, we are going to be graphing using the cave compass, which is a really nice tool for cave sketching. I honestly wouldn't do it any other way, but you can use a traditional compass that has like a dial like this in a similar way, but this one does have a lot of features on it. And linked in the show notes somewhere is where to get this thing. But I highly recommend you use a cave compass starting out on a first survey or anything like that. So we're going to go into, this is this data that our point and front sight person collected that we recorded. So they yelled this back to us from S1 to S2, instead of A1 to A2. So you're standing behind these two guys. The front and point person yelled this data to you. They gave you a distance, which is that distance there. They gave you an azimuth, which is this bearing here. And they gave us a Clino as well as a left, right, up, down, which we're not really going into yet. But that data came from those people. So using the cave compass, we're going to demonstrate it here. On the website, you could Google cave compass and you'll find this. Is also a really nice video and a cheat sheet for it. So it's got a whole little handout. It doesn't come with it, but it's on the website. So if you buy it, it's not going to like ship with it. But if you just Google cave compass, you'll be able to find the handout if this doesn't quite jive with you. But we're going to kind of go right into the graphing portion of this. As a sketcher, if you're fed this information and you're flipping your page and you're ready to sketch on these 1-inch grids with 10 mini grids in between them, you have to put what direction north is and the scale. Because if you don't put that, you have nothing to reference your sketch to. And when it goes on the computer or when it turns into a real map, there's going to be a lot of problems if that information isn't available. So every page you do, you have to start with a scale which can be written in any way you want. 20 feet equals 1 inch. So if this is an inch and these are 20 feet and there's 10 little boxes within each little box is 2 feet. 20 feet to the inch is the most common thing to sort of use, but you can go 40 feet to the inch.
And I'm going to interject real quick here.
Yep.
What
Let me know
Beau
if you
is
need the
sketching
screen.
right now is specifically the plan. So you can see he's got the distances and the azimuth, and what he's focused on right now is he's just graphing what would have been a plan view, because the azimuth only pertains to the north-south, the northeast, southwest. And then reason why he's crossed out Clino is because he's not drawing the profile plot yet. He'll show you that in a second, but the Clino is then used only in that profile. So just to give some context why everything that got crossed out is crossed out.
And think about why we need a scale and why we need north here as well, as we start this sketching. But we have 20 feet to the inch. It's never a bad idea to say if it's plan or profile view if you want to add that note as well. It does not hurt. But we're going to make north in this case up. I recommend, as you're starting your sketching career or stint, put north up to start. As you get more comfortable with it, you can move north all sorts of different directions. And moving north all sorts of different directions just kind of always ensures you're sketching from the bottom of the page up, which is kind of a natural progression. But when we focus north on up only, sometimes we'll be sketching to the right, sometimes we'll be sketching to the left, sometimes we'll be sketching down, and that might make more sense here in a second. So to start, you need to put a point within your system here. You want to make sure your point's not going to run off the page, but we're not going to get into that quite yet. We're just going to talk about how to use this cave compass. So I'm going to make my first point there. And I'm using a really thick lead, hoping it shows. I have a pen here too that we'll use if we need to. So someone just let me know. But our first station is going to be called S1. And over time, personally, I've started transitioning my stations to little triangles. I know that's a little rough looking, but just them being little triangles have helped when I, use circles for other things or little dots for other things. So I'm gonna do little triangles. And so we have a station. We know which way north is. We know what our scale is. And our first distance that we have is 37 feet. So I can use this, and line it up right there. And I know that 1 inch, so the cave compass is all set up to kind of be used with this already. 1 inch is 20 feet, or every little tick is 2 feet. So I can go 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. But I need to go 37 feet. So I know this is 30, 32, 33, 34, 35, 36, 37. However, well, what the heck? Where do I do it? Do I do it down? Do I do it up? And that's where we got to use the azimuth. So 73 degrees is the azimuth. There's a second number there that's the exact opposite of 73 degrees that the point person took, the back sights. As a sketch, I mean, we could draw, we're not going to get too far into it, but the front took front sights and the point took back sights. The front sights went here. It was 73 degrees. And the back sight was 250 degrees, kind of going this way. So just as a little bit of context for that. But right now, as a book person, your main priority is to make sure these numbers are opposites. The easiest way to do that, there's lots of ways, is to simply dial in your compass to 73. Doesn't look too bad. So 73 matched up with that little black thing. The opposite of that, if you look, is 253. So you can kind of imagine, the front person took it one way, the back person took it the other way. And as the sketcher, you're the one who's supposed to catch that. So if the front person took 73 degrees and this is like 270 degrees instead of 253, there's a major error. The device is wrong. There was human error. Somebody took the shot wrong, and you need them to ask them to take the shot again. So generally, things have changed a lot, but watch out for 2 degrees. If these are 2 degrees off, so if it was 256 or 252, you might be asking your team to reshoot it. That's a whole nother conversation. I just want you to know, as a book person, part of your job is to verify this backsite. There's some fun ways like subtracting 200, adding 20, or subtracting 20 and adding 200, or other way around. So you basically have to subtract it by 180 or add it by 180 to some degree. But anyway, since we've already dialed this into 73 though, and checked our backsite that way, we're already halfway, we're already halfway to actually graphing this. So once you dial this in to your azimuth, you simply line your cave compass up with north, and north is up. So we have lined up our cave compass with north after we dialed it into 73, and it's as easy as that. It's as easy. Oh, hang on. Hopefully it focuses. It's as easy as that. This is our 73-degree angle. Notice how, I lined it up to be able to measure out 37 feet. There's a lot of references on the compass to match it to your individual section on your graphing paper to make sure you get it, right up there lined up with north. And once you have this angle, then you can put in your 37 feet. So I know that's 1 inch, so that's 20 feet, 22, 24, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. I'm going to turn into a little triangle. Connect those two and label my station S2. So I'm going to do it a little faster this time. For the next one, we're going to go S2 to S3. And then we're going to look at this again. We're going to kind of switch gears, explain something, and look at this again, but with the Clino data. So S2 to S3 is 25 degrees for your azimuth. The opposite of that, they're saying, is 205, so we have to check that. But right away, you're like, okay, I'm sketching this cave. I got to move fast. They're rambling data to me. I wrote the data down. First thing I do is I just dial this into 25. So the cave compass is dialed into 25. Then I know that I need to line this up with north. Again, it's hard to do it over here because it goes off your page. So, you might have to switch the sides that you line it up on. Once you have it lined up, you can measure out 28 feet. I know that 1 inch is 20 feet. 2, 4, 6, 8. Put a little dot in there. I'm going to turn mine into a little triangle. And that's S3. Your electronic versions of your caving instruments like TopoDroid, they'll do this graphing for you. So as your front sight takes data and the back sight too, your tablet will automatically graph this. So you're skipping out on this step when you use like electronic survey, which is kind of nice because this can get a little tedious, especially when people are rambling tons of numbers at you. Keeping the book is tedious in general. However, and then quick check, we talked about 25 and 205. If I dial this back into 25, I can see that the opposite end is 205. So that is an okay shot. They don't need to retake that. However, with drawing a plan view, you actually do need to pay attention to the Clino. And we're going to graph this again, but with the Clino data. But first, we're going to explain why. So just another thing that I'll kind of watch out for. And the reason is high angle shots, which the cave compass is actually quite accommodating for. So I have a chart here, and this exact chart is actually on your cave compass. It's over here, and it continues over here. Going down the left side of the chart, just like in this one, is feet. So how long the shot is. We did like a 38 and a 20 something foot on the last example. And then here's your inclination. So it's going to be your clino. Clino is the vertical angle of the shot that you're taking. So how up or down the device is when they shoot it, essentially. The reason why high angle shots are a huge issue with plan view is because if they get really high, like 85-degree angle, so that's nearly up or down, a positives up, negatives down. So you're nearly looking straight up on an 85-degree angle. That really starts to adjust your footages. For example, 100 feet at an 85-degree angle only shows up as 9 feet in the plan view. That's a big deal because you're only going 9 feet on your inch instead of the required 100 feet. So we're going to show one example on a profile and a plan, and then Stephanie might jump in as well. And what we're going to do is we're actually going to take, where is it? Going to kind of got the unedited version here. We're going to take S2 to S3, which is the same shot we just sketched. But we're going to take into effect or into factor, we're going to factor in negative 75 degrees inclination this time. And then we're going to compare the two. I'm just going to write it down here though. So I don't know if I'm going to be able to show them both. 28 feet, 25 degrees, negative 75 degrees. Generally, this, like, if you mess this up in cave and you don't affect for a high angle shot, you know, the cartographer, when they look at it online, can fix it a little bit. But it is going to mess you up a little bit in cave when you put all those details there. Some of that's not even going to be possible to show on the real map and all that stuff. But S2 to S3. Was 28 feet. So if we look over here, you know, we're in between 25 and 30 feet. And it was a negative 75-degree angle. Azimuth doesn't matter on this chart because this is a high angle shot chart. Negative 75 puts us at 75. And that is going to match up to about 7 feet, in between 6 and 8 feet. So instead of 28 feet on the plan view, it's actually going to equal 7 feet. And if we graph the profile version of that, which we're kind of jumping ahead here, and we haven't talked about profile, but it is going to kind of get into the cosine stuff of it. I'm going to graph it really quick, just so you guys can see this. I wish I had one done, but I do not. So this is a technical, I don't know if I'm going to be able to do it easily. I'm going to ballpark it a little bit here. 20, 2, 4, 6, 8. We haven't talked about profile yet, but this is a 75-degree angle shot. 75 degrees is pretty close to straight down, with 90 being straight down, so it kind of looks right. S2, S3. What's interesting here is that this 7-foot answer can be found in your profiles. This bottom, I'm just going to draw it with some arrows to make it stand out a little bit. This bottom section is 7 feet. If you count your little boxes, you're going to get about 7 feet. I could have had some human error in there. However, this side is 28 feet, like it's supposed to be. So the plan view is you looking down from the top of the cave. So you're looking down on the 7 feet. So in your plan view, 2, 4, 6, you only sketch 7 feet instead of 2, 4, 6, 8, instead of 28 feet. Whee!
Bo, if I can, I'm gonna share my screen real quick.
Yep. And we'll go back to the high. We're gonna go back to the worksheet after this, but high angle shots are a thing. And you got to watch out when you're sketching plan for high angle shot. Hang on, I'm just trying to figure it. There we go.
Okay. Are folks seeing my sheet of paper here? Yes, no?
Yes.
Okay, cool. So sort of the thing, just to give it an example, why we do the high angle shot correction. And this is the high angle shot correction only exists for plan. So in cave, for example, we had a pit, and that's really sort of the scenario that we're going for. Another scenario may have been, I had a rock here, and maybe there was a slight declination in this case where I shot from rock to rock. Maybe this is only a 20-degree angle or something like that. So it is relevant in like horizontal passage as well, where you shoot from one rock down to another rock, and maybe you shoot back up to another rock up here or something, or on the wall. But where it makes the most sense from a context standpoint is if we go back to Beau's 28-foot pit, 28 foot over there, 28-foot shot rather. What we're really looking at is there's your point person went down the pit already, and they're standing down here, and your front sight person might be up here still, and they're going to take data and shoot down from this point down to the point that your point person's at. And that's the data that your device is reading out, is that 28 feet. But the reality is that on the plan view, the distance is actually this segment down here. And that's what Beau's talking about as the 7 feet, is that on the plan, which is the floor plan of the cave, the actual distance from this person to this person is actually just this 7 foot, but the laser data is showing 28 feet because it shot that. And then of course, if you did some trigonometry, this is the actual pit height. So the 28 isn't even really the pit height either. This person here would have had to shoot straight down to get that pit height, but they shot across to this person and got that 28. So really what that high angle shot correction is doing is it's taking the cosine of this right angle triangle, and that's how you get that 7 feet. So just for an explanation of why you're doing that correction, it's just the chart is doing the math for you instead of you having to do trigonometry in cave. You're just noticing that my angle was high. You go to the table and you're like 28 feet at a 75-degree angle. Turns out it was this distance here. So to give that a little context, if that helps anybody understand it better. All right, that's all I had to say.
Yes. All right. Let me just get this back. All right. I looked at the time too, so we're gonna move on from sort of just graphing to cross sections, then plan, then profile. That's really all we can do realistically, online. Otherwise, we're just gonna be watching me draw. which will get weird eventually. So the high angle shots, this is correct right now because there is no Clino. But if we introduce the real data, on your plan view, 37 feet is not 37 feet. On your plan view, 28 feet is not 28 feet. One thing you could do kind of getting started is as you're taking the data, you can check your compass. So just some quick conversions here. 37 feet at 20 degrees would be 35, 20 degrees at 34. We're going to call it 34 feet. So you could put like a little 34 there, technically, for you. But I would erase it before you submit it to your cartographer, because otherwise that's going to get really confusing for them. But if you keep forgetting over and over again as you're sketching and the craziness of it all, you could put like a little number there. And in this case, for the 28, you'd put like a little 7. And you can see where, okay, if you forget on all your 20-degree shots that are a lot of distance, it's really not that big of a deal. But if you forget on a negative 75-degree shot over a decent bit of distance, it's going to start causing some issues on the tail end of the map making process. It can be fixed. There is no problem with it, other than it's going to be a big headache and things might not be exactly where they're supposed to be. Plus, you're going to use way more paper. All right, we're going to jump into cross sections. Do a little example. Get it to focus. And you can see I have highlighted when you're taking the data, the only data really important to the cross section is your LRUDs, your left, right, up, down. LRUD. So your LRUDs are something that your point person usually gives. I don't know, equal sign, whatever. Your point person usually gives you the LRUDs. Your front sites can give them as well. It actually doesn't matter which one, depending on how your survey team does it. But an LRUD means that at station S1, the left wall is 8 feet from station S1. The right wall is 7.5 feet from S1. Up is 18 feet to the ceiling, and down is 2 feet to the floor. So you can start getting an idea of what the passage looked like around the station. Same thing for S2. 411, 4.3 are the passage dimensions. S3, same thing. And a cross section, the best way that I had to show it was taking like a slice of bread. And this part is the cross section. And S1 is sitting somewhere in the middle of it. So that's the portion that you're drawing when you're drawing a cross section. If you are looking to sketch and you are like joining a sketching team, definitely ask them if you can just help with the cross sections. They're the easiest things to do, and we'll show you. That they're very forgiving. So to do a cross section, and we're gonna kind of this is sort of a checkbox to get people like looking at the cave symbols. So we're gonna take a look at this and try to put some of these formations in here just to give you some practice of looking at formations or how that process would go if you're underground. But there's symbols for everything you sketch in cave. This is a symbol sheet just off of Derek Bristol's website. Gives you some ideas for how to draw rocks, or sorry, mud. You're not really going to get into strike and dip geology on your first surveys. I don't even do that, but if you're into that stuff, those are some symbols for that. Small rocks, breakdown, sediment floor, clay, passage height, pit or depth height. These are all think of these as all tools for sketching your cave, because again, it's a lot of symbols and a lot of processes. It's not a lot of art. Speleothems have all sorts of different things that you can use for them. You could use anything you want for a symbol, but you have to label it somewhere on your page if you're not using something that's standard. Soda straws, pit, dome, it's a whole nother sort of concept that we could get into on this. There's our slope. Remember, we sloped the rock earlier. So we have these sheets are like readily available. You can find them online, but you should have one of these when you go to sketch. Even if you're just doing your cross sections, this will help you make sure you get stuff in the right places. Some of this is plan specific things like ledges and pits and whatnot too. But to do a cross section, so if you are just helping out with the cross sections or you're ready to put in a cross section, usually the rule of thumb is to do a cross section every major passage change. So if it changes from like a phreatic tube to like a canyon passage, you at that changing point, you might put a cross section in. Some people say every other station, some people say every station. So it definitely depends on the project you're doing. If it's for some like crazy state park or something and it's really high levels of sketch that's needed and lots of data needed, the person working on the map might ask you to do cross sections at every station. But to do a cross section, it's pretty simple. If you have a nice big piece of paper, we're just going to put it dead in the middle in this case. You could put it anywhere, but for making this easier, we're going to do the middle, and we're going to decide which one we're doing. So let's do C1. So our cross section is going to be C1. Left is 9 feet. So since this is scaled out, you really don't need to use your compass, but you can. 2, 4, 6, 8, 9. Right is 1 foot, so it's like really close to it. Up is 4 foot, 2, 4. Down is 4 foot, 2, 4. Swoosh. See if it focuses. Maybe not. Okay, so the next thing you would do is do your walls. So you'd put your dots in your left, your right, your up, your down, and then you do your walls. And you would physically be standing in this passage, which isn't too high, like large. It's 8 feet tall. But you would be looking at the ceiling and you would be asking yourself, okay, directly above the station, is it going up? Is it going down? Is it curving? So it's a little bit of make-believe right now, but I'm going to say it holds that height and then it really shifts down, and then it goes like that. And then it holds that again, shifts down, again, kind of making this up as I go. All right, so just walls. So you really are, it doesn't need to be perfect, but if there was like a section of this passage that was sort of a spot you could fit yourself into right there, as we look at this as the slice of bread that we are in, you kind of want to get that stuff in. There is a little ledge to the right of me. I put in a little ledge there. It's only, hey, arguably it's almost 2 foot wide to scale. So in a passage that's 8 feet tall, that's a little significant, and only 10 feet wide. Okay, so you get that in, and then you're going to start doing your features. So this is where you're going to look at your symbol sheet. Okay, and we're not going to like sit here and review the symbol sheet. There's different ones out there, but it's a reference you should have as you kind of get into this. And I'm going to show bedrock because it's part of my checklist here to try to push people to use our little symbol sheet. We're going to put limestone on the walls because that's what it actually was in the cave. So that's a symbol for limestone that you can use. We got limestone on the ceiling. We got limestone on the right. We got limestone on the left. It's not mud fill. It's not like rock and all that. I did not put a ceiling canyon in, but if I did put a ceiling canyon in, it would look something like this. That would be a ceiling canyon and you'd be like standing below it. So you don't make a symbol for a ceiling canyon in a cross section. You like physically draw it out because you can. So walls, walls are something you truly look at the cave for. Floor detail. Let's add some floor detail. In this case, we can choose. We're going to do mud or clay floor, so it's dashed lines like that. And so you could put some details about the floor there. So it's a mud floor, limestone walls, and then two formations. I don't have much room here, but I'm going to put a stalactite in. I'll just color it in because it kind of looks neat. And I'll put a stalagmite in as well. Again, it's a mix. Depending on your view, kind of depends if you're using symbols or not. I arguably are not using symbols there for the stalagmites and stalactites. However, you could. The symbol for a stalactite is sort of a Y like that. A symbol for a stalagmite is that flipped over. So I could put those symbols in instead of that. So it was a little artistic, I guess. Not that it's amazing, but so you can use symbols. You don't have to use symbols. It also depends on your view. I use symbols for limestone. I couldn't draw the walls in as limestone. There's no way to do that. I use symbols for mud. Again, I couldn't like draw in my walls showing mud. But that's the cross section. Uh, we're not going to do another one right now unless there's some dying desire to see another one. That's the steps for it. You stand there in the middle of the passage. You take your data, you put your point in your paper. You label it 20 feet to the inch. And you don't need to know a north arrow. North doesn't matter here. It doesn't really exist in this case if it's just a cross section. You might reference it. You'll see things like referenced to the plan view. This arrow, this leads to the plan view. So you may have seen these cross section lines on maps. This indicates you're looking down into this passage. So we're looking into the passage that way. But otherwise, now it's a little marked up. But that's a cross section. Stephanie, any comments on cross sections?
Nope. Looks good.
Okay. The plan view, we're going to do one of those. Again, we highlighted the parts important to the plan view. And we now know that Clino is also important here because we sort of did that step a little earlier than we sometimes do. So Clino is important too, but we highlighted that only the left and right are important, not the up and down. So in the plan view, you don't worry about your up, down. You're just kind of showing the left and right. This is a plan view of the United States. It doesn't show the mountain range heights on it, etc. So we're going to graph the plan view one time, then we're going to move on to the profile view, and then we've looked at all three views. We'll look at a finished map, and then I'll show you the practice activity you can send us after this, and we'll also kind of go over some other things. But we're going to do the plan view on the other page. Oh, I didn't put the that's okay. Okay, Stephanie, I'm going to ask you, should we do the plan view with the Clino changes?
I don't think so. Let's just keep it simple for now.
Okay. We all are aware of what a high angle shot does to these, but in our example, we're just going to worry about a pretty simple plan view here. Mm-hmm. And then we'll do profile. So I'm going to start a point on here. You'll have to be careful when you're in the field. Sometimes you're going to run off the page and that'll come naturally to you. Not really enough time to come up with good solutions for it now. But you're going to put your 20 feet to the inch. I'm going to do north down to show you guys sort of what that looks like. So if you put north down, what does that do? And that'll show, another way of doing this. And we're going to just do point P1 to P2 to P3. So P1 to P2 is 22.2 feet. I want you thinking to yourself right now, okay, what's the first thing I do with the cave compass? Well, we dial it in to that azimuth at 250 degrees. So I dial it in 250. I check the other side while I'm doing it. Oh, look, 70. Wow, that's a great shot. They don't have to redo it. Left is 16, right is 2 at P1. Left is 2, right is 4 at P2. And we're going to start this process. So normally we'd put north up, but north is now down.
And part of the reason that this all makes sense is if you look at the compass as he has it, 0 is north, right? Like the north is pointing to 0. And then east is exactly 90 degrees, south is exactly 180 degrees, and then west is exactly 270 degrees. And so because his azimuth there is 250, it's somewhere in that southwestern corner of the page, of his compass, which if he faces the north down, because the passage is headed south, he can maximize his paper. That's really all he's doing, is he's trying to just maximize how much paper he's using. Otherwise, paper's cheap if you don't face your north the most extended way on the paper. You're just going to switch pages a lot.
And that's a good point. I should have read that. Not a bad idea when you're designating north on your paper. Go ahead and write 0 degrees, 90 degrees, 180 degrees, 270 degrees, north, east, south, west, in this case, with it upside down. And that way you can kind of fact check your sanity, because if you start sketching this way, you can be like, oh, yeah, that actually looks like it's about 250. It's in between 180 and 270, because sometimes you might want to go this way. But if we go this way, we're actually more like 70 degrees, which is not the correct direction in this case. So lining these up, matching it roughly there.
And draw your line basically towards the angle that you just dialed in.
Yeah, that's a good point too.
Yeah.
So I'm going this way. 22.2 feet. So 20 feet is 1 inch. So I'm going from the 3 to the 2. I know that's 1 inch. And then 2 is one more tick. And 0.2 is like just a little bit after that. Nothing crazy there. Can be a little off. And I'm going to put those together. In this, I'm going to do the next one right now, and then we're actually going to put some stuff on here and go through the process. So, all right, take it off. New station's given to me. I'm going to put P2 down here just in case. Your team says, all right, book person, P2 to P3, 17.7. You write down 17.7. They say front sight 200. You write down 200. Back sight 20. And you're like, okay, cool. And then you're like, hey, what are the LRUDs? And they're like, P3 LRUDs. And they'll tell you 10 and 7. And try to, it's 7. Just 7. And you're recording that. And again, that practice of how that team flows isn't something that we could do easily here. But that is part of it, because if you're flowing well, they're giving you data nice and organized, and you're able to keep up with it. But 17.7 degrees at 200. So, starting fresh, you pick this back up. It was in your cave pack. You just dial this into 200. However you want to get there. So 200, you check the back sight. It's 20. All right, 20 is good. It's within 2 degrees. And you line this up with north. Which is down. And this is where, when we're running the class and people are doing this on themselves, we get a lot of people drawing downwards. They just kind of want to go towards north. But if you remember, 200 degrees is more up here, not down here. We go up in this case. It's going to catch you at some point. It gets easier as you keep doing it. Sounds like Stephanie, too, you had some good ideas to keep on track. But 17.7 feet, 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18. So about in there will do. And that's P3. All right, if your team just rattled off to you these 3 stations and you line plotted them, you're doing okay on your plan, but you're missing, the cave. So we also have a little handout to walk you through the steps of this. So I'm gonna just show this once. It's gonna be a little hard to keep referencing on here, but this is something to keep in mind. This is a good, even if you write these out step for step, this is good to have you on your first sketching experience. You plot the stations. We know how to do that. We haven't done these other things, so we're going to talk about them. I'm just going to show them really quick, basically, and that's probably all we're going to do and have time for. You plot your walls. So, if this is a station, this is a station, this is a station, this is my left wall, that's my right wall. You literally just put the dots in. Left, right, left, right. So the second step is always plot your walls. We're about to do that. Then you sketch your walls. You connect your dots. Wall, wall, wall. This wall goes crazy, etc. And as you're sketching these walls, you're like literally walking these lines. So as you walk through these 2 stations, you can look to your left and sketch the walls in. And you know that about at the second station there, they got a lot going on there. At the second station there, oh, that wall really jets out and then comes back in, relatively speaking. So you can kind of relatively put the walls in as you're walking through the passage, and your body helps add a lot of context. So we've sketched the walls. Then you do ceiling details. Then you do floor details. Then we sketch things like rocks. Then we sketch the really tiny details. And then we rinse and repeat. You just keep going. And that's how you get all your stations in. So following those steps, we have our points. At P1, we know that the left is 16. So 2, 4, 6, 8, 10, 12, 13, 14, 15, 16. We know that the right is 2. So we got our walls in there. Just going to average this one out. For P2, we know that the left is 2. The right is 4. And at P3, we know that the left wall is 10. 2, 4, 6, 8, 10. And the right wall is 7. 2, 4, 6, 7. From there, as so you get this raw data in, you're standing back here and you start physically walking this map, which is a total of you're walking your sketch in the real cave, total of like 40 feet of walking. So you walk from P1 to P2, and as you walk from P1 to P2, you look on your right and you're like, wow, that wall just follows the station straight up. And on the left, you're like, oh, that wall really pinches in quickly, and then heads to the wall. And then you walk maybe from P2 to P3. And from P2 to P3, you look to your right and you're like, that kind of jets out a lot. So you jet it out a little bit. And on the left, it sticks with the station and then it just cuts for some reason. So you're literally looking at the wall and kind of gauging this mentally, how far is that wall from you as you walk this almost imaginary line through the middle of the cave. You got a reference point here that this was 16 feet away, so you can work with that. You knew that this point was 2 feet away, so you have this reference to relatively put your walls in with little with room for error, no doubt, but little room for any serious consequential errors when you start, connecting the dots like that. When your station gets a lot longer, like you take like a 60 or 100-foot shot, you might have you might stop in the middle of the passage and be like, okay, in the middle of this shot, the wall is 10 feet on the left, the wall is 4 feet on the right, to give you some reference point. But these reference points are important because they help you, get your framework here. So the next step was ceiling details. So we're going to put in some ceiling details. We're going to put in a ceiling drop, which is shown like this. I've kind of gone back and forth on how to explain this to people. We can show it. We're not going to be able to sit here and show cross sections for it now. Too much. Well, I guess we could. But this ceiling drop, these ticks, anytime you do the ticks, really, if you do a floor, the ticks point to the same way that these point. The ticks point to the lower passage. So you are standing up here, over here, but as you go under this ceiling drop, these ticks point to the lower passage. In this case, lower ceiling height. You're identifying it's a ceiling drop, and these point to the lower ceiling height. A lot of people do these wrong initially. It's okay. If you do a good cross section, sometimes you can show it that way. But I guess outside of the scope of this right now is showing all of the symbols, at least explaining the tricky ones. Ceiling drop and floor drops get people. So, but we know that the ticks point to the lower ceiling. Likewise, you can have a floor drop. And in this case, the floor ticks point to the lower floor. So you'd be standing up on this 2.5, 3 foot wide ledge and jumping down into this cave passage. So you did your walls, and now we're doing like major ceiling and floor changes. Trying to make sure I hit everything here. A slope could be showed like this. So as you went from P2 to P3, the floor sloped. It was high on this end and low on this end. And you could have that slope be a mud slope. So we could add mud. Now, it is tricky to show mud and show the slope sometimes because they sometimes look pretty similar. So sometimes I'll go in and really highlight that slope if I kind of mess that up. But we have a mud slope, and it is sloping down this way into the cave passage. We could put formations in. Some stalagmites are over here. I'm running out of space, but we're going to throw some soda straws here. So kind of try to sneak in some soda straws there. And at some point you can see where like, okay, let's put some flowstone in too, just to get another symbol in. Some flowstone over there. You only have so much space to put details in, which is why we try to create an order of events. Walls, then ceiling and floor. Ceiling, floor kind of can be either one can go first, but those are going to be major passage changes. And then you get into the less, the less important passage changes, like some of the rocks, and maybe some of the smaller formations. You can edit your order of operations however you do it, but a lot of times I see new sketchers, they put their walls in, and then maybe they put on all their floor detail. So they fill this entire thing up with mud. And then you're like, wait a minute, this floor ledge was pretty important, and this thing was pretty important. So you're sitting there and erasing all your mud or trying to put it over it. And really, the mud might not be the most important thing of the passage. The ledges might be more important. The mud might be the most important thing in the passage. Depends on why you're making your map. So that's the plan view.
And I think that's another point to kind of note with new sketchers. There's this tendency to try to get the whole cave all onto the one little piece of paper. And one thing to remember is it's for navigational purposes. And what you really want to do is take any big landmarks that actually matter for navigation and make sure that they're on there, and try to simplify the cave. You don't have to get everything on there, just the stuff that is kind of important to know where you are.
Sarah, I know bad handwriting, but you could put cross sections in your plan view. So that's marrying the last thing we just did with the plan view. You might decide to put cross sections, in certain spots, just kind of drafting them in. But so what's nice is when you do cross sections with the plan view, the cartographer, the person making the map, knows exactly where that cross section was. When cross sections are on separate pages, you need to be very careful about, how you connect it to the plan view. If you're doing cross sections on separate pages, you should probably only do them on stations. So you can just label this cross section as like, you could actually put like P1 on it. This is not a P1 cross section. This is in between P1 and P2. And to show exactly where it is, you can reference it to your plan view and put it on the same sketch page. So that's it. That's the plan. I'm still watching the time here. We're going to move on to profile. And just a reminder, when you're doing plan view, try to, we can send you reference pages, but have some order of operations either memorized or that you can reference, and have a symbol sheet that you can also reference. And keep in mind, it's going to be slow when you're checking your symbols and checking your order of operations, but it just starts slow, and you just get faster at it as you just kind of keep doing it. And that's just part of the process. For the profile view, we definitely do not need azimuth. We don't need left, and we don't need right. And we are making, well, here's an example of a profile of the United States, plan view map. So this was the plan view. This is a profile of the United States then on, an imaginary line cutting through the US. Over on the western part of the US, you got mountains and stuff. On the right side, you have the Appalachian Mountains, and they're not nearly as tall in this case. So we're going to be sketching this view of the cave, this view, of this section. Sketching the plan is a little different on the cave compass. So instead of using, I've been referencing everything to just, when I hold the compass up, I've been referencing everything to here. There's some other references you can use on this thing, but that's just how I've been doing it. I've been referencing this dot. I've just been lining it up and then matching it with north. For the profile, we're going to use this sort of inner bar. You can see it has 0, minus 90 is up in this case, which is not what you would expect. And plus 90 is down in this case, which again is not what you would expect. And we move this dial. You can see sort of the thing under the 90 there is a little tick. And that little tick under the 90, we're going to match that up to what our inclination is. So in this case, I have it on minus 10. Now it's in minus 20. And that's what you're going to do. When you choose your azimuth or your clino, you're going to match it up like that. So in this case, we have S1 to S2, 37 feet is what your team told you. They said it's plus 20 and minus 20 for the back sight. So the front sight giving you plus 20 and the back sight giving you minus 20 means that it was a good shot. They're exactly opposite. So clino is way more forgiving than azimuth. If this said minus 24, we might have them retake the shot. If it says minus 16, we might have them retake the shot. And maybe the front sight was the problem there. But either way, it's easy to double check the front sight and back sight, which again is kind of falls on you as the sketcher. Up, down, so directly above the station at S1 is 18, directly down is 2. For S2, directly above is 4, directly down is 3, and so on. So I'm going to just start S1 here, do a quick graph. S1 is plus 20. So I'm kind of holding the cave compass sideways now. I'm going to go plus 20, which is down in this case. And once I have that on plus 20, I just line north up with up. Or a better way to think about this, though, is line the bar that you use to dial into 20, line that exactly horizontal. So once that's lined up horizontally, this is my 20-degree angle. So it's that simple. 37's our first go, so I'm a little high up on the page, but I'm going to run with it. So that's 20 feet. 1 inch is 20 feet. 2 inches is 40 feet. And I'm going to go down 3 feet to here. And the angle that it created was a 20-degree angle. That is S2. And one more time, I'll show it one more time and then kind of go over the sketching for the profile view. So S2 to S3, minus 75 degrees, and it's plus 75 on the back sight so that your team doesn't have to retake the shot. You dial in minus 75, which is way up there. Make that line horizontal. And we're going down because it's a negative number. So we're going down minus 75 degrees at 28 feet. So 20, 22, 23, 24, 25, 26, 27, 28. So we're not doing 7 feet. We're doing the actual 28 feet because we're sketching the profile. I'm going to label that down here just in case. So if you got these 3 stations from your team, you're going to follow similar steps to the plan view. You're going to do your ups and downs at each station. So S1 up is 18. I know that that's an inch, and I subtract 2 from it, 18 feet up. 2 feet down, it's going to be 1 block. For S2, up is 4, 2, 4. Down is 3, 2, 3. And for S3, which they barely got in there with that floor, up is 13, 2, 4, 6, 8, 10, 12, 13. Down is 2. All right, so we're going to do a little more make-believe here, but as you're walking this passage, you're looking at the floor and the ceiling. As you walk through S1 on the floor, you're literally walking it. You see that the floor is kind of bumpy. Bumpy, 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 kind of goes up, but then it really shoots up like a wall that you have to scale. So you walked that, or you visually saw that, and you put your floor in, and then you look up and you saw your ceiling is a pretty simple ceiling, very, very flat, but then shoots down right in the middle of the passage as you're walking it to S2. Your ceiling was limestone, so you just kind of put the limestone bedrock symbol there. Your floor was mud with some rocks, we'll say. You know, you could even have like a rock sort of jutting out of your profile that you had to climb over. But this ledge was bedrock. Now, we're kind of skipping, not skipping, but you know what? We talked about sketching the walls and ceiling details and floor details. In the case of the profile, you're actually sketching those ceiling drops and floor drops in. So on the plan view, if this was a plan view between S1 and S2, oops. Well, this kind of works. You would have a ceiling drop here, pointing to the lower ceiling. And you'd have a floor drop pointing to the lower floor here. So you're not actually using symbols for those. You're literally putting in those floors and ceiling drops. But here, you can actually see that this floor drop was 2, 4, 6 feet of a floor drop. You can tell this ceiling drop was really only like 3 feet of a ceiling drop. You don't really get that on the plan view, but when you marry them both together, you get a lot more context. For the last part here, this was a pit. Ceiling went straight down. Cave continues. Again, a pit went straight down. Kind of, maybe it did something like this. Again, a little bit of make-believe. And there's water on the bottom. Yay. So you can try to like add flowstone into the outside of the walls and be like, this wall is flowstone. You can get creative with it. You could try to put things into the plan view, like a stalactite at the top of the pit that you noticed. You could even be like, yeah, you know what? There was a lot of water dripping off that stalactite. This looks more like a waterfall, but you can get creative with the different views and all that. But for the most part, um, you don't need to do too much detail in the plan views. Like this is a lot of detail, or sorry, profile for a profile view. You certainly can. But if that detail is shown really well in your plan view, you might not need to necessarily like show it again or vice versa. In this case, showing these ledges and drops and stuff adds a lot of context to the plan just by doing it to scale. So that's the profile view. And if I said plan instead of profile a few times, I apologize. Stephanie, profile. It's kind of the last thing.
Yep. Um, you know, I have no additions to it. Thank you very much for leading all of this. If you didn't have anything else to present, I think we can open the floor for any questions that were still lingering.
Yeah, as people do that, the only thing is, a full cave map shows the plan view, cross sections, and a profile. And all three of them together add a lot of context. We have a scale and all that too, but looking at the plan view and then looking at this really gives you a context of where this cave is in the world and maybe some help for navigation. And then if anyone's interested, this is a worksheet I can send you where you can try to graph these 6 points on the below graph paper and make a plan and profile and cross sections, and then also give this map like a title and a scale and label your plan and profile, kind of making it similar to a complete map. So if you want to complete a capstone cave yourself and send it to Stephanie or I, we'd be happy to look at it and just check these boxes as you add these things to your plan view. Like for example, one of them's hydrology. That means looking at, Derek Bristol's symbol sheet and adding something with water involved in it. I think one of it even labels hydrology. So you could have a pool at the sump, flowing water, anything like that within the map that you sort of create. So that was the last thing.
Awesome. Do you have a link for that, or do you want me to upload it somewhere?
We'll upload it. I don't know where you've been uploading stuff right now, but whatever. I don't know if it's easy to upload it to every event, but
I've been putting it just in the one event because I'll upload this video
okay.
and then we can upload it at the same time.
Yeah, wherever you're uploading the video, we'll upload the worksheet that anyone is free to do and get some practice in.
Okay, cool. All right.
Hi, this is Bruce. I have a generic question.
Uh-huh.
Yeah. So I'm just looking at the amount of time it takes. You're going to draw, at a given station, you're drawing your plan, you're drawing your profile, you might be doing some other things. It seems like it takes a fair amount of time. How long do you usually spend at a station before you move to the next one?
So that sort of depends. I like to divide the work up, actually. I'm a bit of a lazy sketcher myself, and I believe everybody should learn how to sketch. So basically, my point person and front sight person also get some assignments. So oftentimes the point person might also be drawing cross sections, and the front sight person may also be doing profile. And so if everybody knows how to sketch, it goes a lot faster because then each person only has to draw one view. To me, the plan view takes the most time. Um, and um, and so if I can have the other two people also do the profile and the cross section, even though they have other jobs, it splits the work. All in all, when you get pretty proficient at it, the plot actually ends up taking the most time out of the whole thing. And then picking out the symbols and just kind of doodling them in doesn't take too much. I will say that we have mentioned TopoDroid. This is not meant to be a brag, but I can still out sketch TopoDroid on paper. And part of that is, even though it automatically plots for you, labeling all of the stations and data actually takes me longer on the computer than it does when you get very, very proficient with paper.
And Bruce, it is time consuming, the pure line plotting of it. There's no kind of way around it, but it does get faster, but really it's super helpful if you go if you're sketching for the first time and you have somebody that can at least take the cross sections. It does help a ton. But yeah, all three views, I mean, it's a lot. That's why I kind of do cross sections only in major passage changes, or try to get someone else to do them all together. But it's hard to put a time on it. I haven't really thought about how long it takes me. But usually 20 stations is like really good for like a day trip. But more realistically, you'll get like 10 in. You might only get 5 in on your first attempt at this stuff.
Yeah. Like we did a grotto survey this past weekend, and we had 4 new sketchers during that time period. And they were all trying out the different sketch views. And all in all, in about 4 hours worth of work, maybe 3 hours or worth of work, they got 8 stations plotted, equivalent of about 300 feet. So I was really proud of them for never having done this before, to get 8 stations and 300 feet done. It adds a significant amount to the cave.
Okay. And then I noticed, Stephanie, you were using a book, it looked like. So I'm just wondering, versus the piece of papers that were being shown, the book is plastic, the papers, you should laminate them for like the legends and stuff. Your recommendations just for how to proceed.
Yeah, so in the event details on Facebook, I'm assuming you found this on Facebook.
Yes.
I put some links to where you can buy the paper and the book. And the book is just a ring binder made by Right in the Rain. Right in the Rain is a company that makes waterproof paper. I don't know what they really put on the surface of it. It's either some form of plastic laminate or a wax. If I'm not mistaken, it's like Beau is actually a retailer himself. So if you go to his website, it's Custom Survey Pages. Is that correct?
It's Custom Cave Pages because the domain was taken for Custom Survey.
Okay.
Custom Cave Pages. Intermount Outfitters though, and OnRope One also sell, but this is the binder that most cave surveys are going to be using. It's an NO9200T. I guess that's the actual part number. And then these are Right in the Rain pages, so they're printed on waterproof paper. The actual sketch pages. Again, there's multiple places to buy them. I'm customizing them on customcavepages.com, but you can buy like pre-made ones already too. But generally, this is kind of your setup. You have your pages in this binder, and you're sketching off of this binder in Cave.
Yeah.
Okay, thanks.
Yeah, and all those supplies, including the cave compass, were linked in that. But yeah, it's I bought pre-printed ones. I didn't buy any of those paper yet, but it'll have the graph page on one side, and on the other side it'll have the data sheet. And so as you're in cave, basically you're just going to be copying all the data down onto the data side of it, and then on the other side, flip side, you can start drawing on that.
Oh, perfect. Okay, thanks.
Yeah.
That's a way better example that you showed.
Well, I just had a pre-filled binder. That's all I've got. Cool. Any other questions?
We are
Alright.
hosting an in-person where we try to do it in just a day. We're gonna run through the PowerPoint really quick. We're gonna run through the sketching practice
Examples.
so everybody can practice that, and then we're gonna head over to an actual cave project that we'll be starting with the group. I don't remember the date. April?
April 12th in Rock Castle, Kentucky. So if anybody wants to do that, the Kentucky Speleological Survey is sponsoring us this time, and we just want to make sure that the future of cave survey does not disappear. We want people to actually know how to do this, and if you just need practice, it's really great to just find another cave, find some friends, and just keep at it. That's how you get good at it, is just keep doing it. And like I was saying earlier, we picked a cave that was in bad need of resurvey. I mean, all of those bad cave maps, from like the ones that people get lost in, or there's just an ancient map from the 60s or something like that. There's no harm in resurveying it. And those are really nice caves typically. So
And when
how do you sign up for the event? You just
Okay.
show up. I don't have a registration or anything for it. The event is on the Facebook for Greater Cincinnati Grotto, so you can just hit, going on the Facebook event, and all the details are there for how to get there.
Before the event, we might make like a Google form to fill out just to tell us you're going
Get a
again
better
and
head
get some
count.
information. But yeah,
Yeah.
it doesn't cost money.
Yeah.
When we do the event, we will be once we're gonna run through this class again, actually practice in groups on like collecting data, go to the cave, and after that, we're gonna host some online sessions of that data that you took after the class and putting that on the computer and making a full map of it. So we try to take the core group that goes to the class and whoever is interested, walking them through the entire process to a final cave map. 10 to 15% of people stick with that portion of it. People still go survey the cave afterwards, but we do that as well.
Yep. Cool. And just as a plug, for if you guys have future topics that you want us to cover, it doesn't have to be cave survey. It could be something else. We'll either do a presentation, or we'll find somebody to do a presentation who's more knowledgeable about the topic. But yeah. I hope you guys enjoyed it. Thank you, Beau. It was a lot to have to
That was
put
a lot on the
together.
computer.
To
If you
graph
guys have
live
any
in front of people.
if anybody has any questions, reach out to Stephanie or I anytime.
Yeah.
If you just want to get into this and just want to ask about where to get the stuff, where there's some caves you can do. When we're doing a survey trip, or if anybody in your area is doing a survey trip, just hit us up. We'll try to help.
Yeah, we've got a pretty good network too. So, all right. Well, thank you all for joining. We'll see you again soon.
I love you all. Goodbye. See you, Stephanie.
See ya.